we're still on organic chemistry, and it's quite a big section, okay, and we're going through it at a pretty good pace, I think, hopefully not too fast, but we're trying to get our recipes in order, and we're now going to look at the next stage of this. I'm going to look at a process which we call, and it's actually this, we're starting to do reactions here. We're actually starting to do reactions. I am going to do the first one called Esterification. Esterification. What's that all about? Well, in proper language, it's making esters. Okay? What are esters? Right. Esters are basically, we take a carboxylic acid and an alcohol, we mix it, and we get a really cool smelling one. If you go onto the internet and you go and look up esters, there's some cool tables that show you which acids and which alcohol you mix if you want to get strawberry, mushrooms, bread, whatever. So you manufacture cool smells, all right? So we can now manufacture, instead of taking a strawberry and going and squishing it and getting its juice to do something, we can manufacture something that has the smell, the aroma, and hence it's going to give us that nice word smaced, the smell leading to the taste of a strawberry. Okay, everyone's got their own particular favorite, right? Some people, one of my students, she really doesn't like banana flavored stuff. She's cool with bananas or whatever, but not the flavor. She doesn't like it at all. And you get people who don't like pineapple flavors and things like that. Let's look, how do we manufacture an ester? Okay, so just follow the recipe of this, okay? And every single esterification problem is exceptionally simple, forwards and backwards. Okay, so consider the following process. We are going to start with hexanoic acid. Let us say we are going to start with hexanoic acid, okay? And we are going to mix it with an alcohol at a later stage. I don't know what I mixed it with. Hexanoic, ethanoic, citric acid. All right, let's just start with hexanoic acid. And first of all, we're going to mix it with water. All right, what happens? Well, it's an acid and it's hexa. So I must go 1, 2, 3, 4, 5, 6. Fill in our stalks. Hang on, the acid was, how do I remember this? Acids are ending COOH, right? Ku or kuh, whichever you prefer. It ends COOH, okay, like that. That's my hexa. And how would I have labeled this? Let's just recap. 1, 2, 3, 4, 5, 6. Hexanoic acid. I think that's the one that smells like goats. I'm not sure. Okay, red, remember, this is our oic acid. Right, that's what it is. Now we said we're going to put it in water. Remember we said before, acids are proton donors. So this hexanoic acid is going to give off a proton. Which proton does it give off? It gives off the H from there. So it leaves me with 1, 2, 3, 4, 5, 6. And yes, it does become a pain doing this. And it leaves us with the O. And it leaves us with an end, and it's a minus. This leaves us thus with an ion because it's charged now. Remember we went through that previously? Just recapping. The OH, the H is gone, so it leaves me with a minus side. So therefore, the H, this is a hexanoate ion. All right? Okay, that's the acid. Now let's mix this with an alcohol, for example. If instead of the water, okay, we had the alcohol, all right? Let me just leave that as an H2O there. Sorry, let me just leave it so that I can come back. Let's rather now take a simpler one. Let's take, I think I took, no, I'd rather take an easier one, just a simple one. Ethanoic. Let's take ethanoic. Meth, eth, double bond O, OH, like that. And let's mix this. This is ethanoic acid. This is ethanoic acid. Let's mix it with methanol, ethanol, propanol, or let's say butanol. Butanol. So I'm going to mix it with bute. So it's meth, eth, prop, bute. Meth, eth, prop, bute. Alcohol was an OH, correct? Like that. So I've got ethanoic acid plus that. Now, that always gives me an ester, which is an O8, plus water. That's the standard reaction, and yes, you must know it. An carboxylic acid plus an alcohol goes to an ester plus water. Okay? That's a standard reaction. Let's look at how this occurs. This is esterification. First of all, the ethanoic acid comes along and it gives off the H, correct? All right. CCO and my double bond O, and there's my, and this is my ion, and I've got an H plus sitting there. Plus, this character here gives off the meth, eth, prop, bute. All right, like so. This one gives off the OH. Okay, right, leaving this with a plus. Correct? Because OH was minus. All right. Can you see that? So I've just split up the acid by taking the hydrogen off. That's what an acid does. Donates the proton. The alcohol loses the OH portion. And what happens now? There you go. That forms your H2O. Right? And then the two pieces that are left. The two pieces that are left here. There, that, and that, they get together. Well, let's look how they get together, shall we? Come on. I've got my C, and my O, right? And remember, I'm a minus there, right? Like that. This has got a plus side. So it turns around and it says, hang on, I've got a plus side here for you. So this guy turns around. You see it? He turns around. Forgot my timer. I do that all the time, don't I? So he turns around this way. Because after all, he's left with a plus. And this side was a minus over here. So there's an electron there and there's an electron there that are waiting to get together. So they join. And what do we then get? Well, let's join them first. C, C, O, double bond O, C, 2, 3, 4. Can you see? All I've done is I've just joined over here these two. There it is. There was an electron waiting, and there was an electron. Now I can make a single stripe because my electrons have bonded. So what do I have? Okay, family group first. Family group, that tells me it's an O8. O8, label the O8, find the green, the chain of the O8. It's 1 and 2. So it's a meth-eth. It's an ethanoate, right? And then the side chains that are added onto this is that guy there. And that's meth, eth, prop, bute. That's butyl. So the final name of this character is butyl ethanoate. Butyl ethanoate. There he is. All right. Now, you can do that in reverse. All right. We'll do one in reverse in a few minutes. Okay. So essentially, when we're mixing a carboxylic acid and we're mixing it with an alcohol, the acid gives away its, which is an oic, gives away the H, okay, to form the O8 ion, methanoate, ethanoate, propanoate, etc., hexanoate ion. It's a negative charge. It's got a stick hanging there out that's lost an electron. The alcohol, the whole OH goes away and forms with the H we lost to form water. Then what happens is the alcohol turns around and it comes and joins in onto the other side. If they asked you what has to form, okay, how would I form, for example, I don't know, propyl hexanoate. No, pentanoate. Right? Propyl pentanoate. Okay, well, first of all, this is an ester, right? Okay, which means I've got to split it up. So I've got a pentanoate. So let me draw my pentanoate. Meth, eth, prop, but, pent, O8. There we go. Like that, right? That's my O8. There he is. And it's labeled from the side, the green end, like this. 1, 2, 3, 4, 5. Pentanoate, right? That's my O8 ion, my O8 family. O8, not O8, right? It's an O8 family. Then onto that we had the side chain was the propyl, right? So the side chain goes there, and that's going to be meth, eth, prop, and that's what we stick onto the side. That's that. Now what comes from what? The green, this was the O8, becomes the acid. So pentanoate must become pentanoic acid. Why? Because there's the water they forgot. That splits to H plus and OH. Pentanoic acid, the H goes to the acid, and meth, eth, prop, that must be propanol because the OH goes to the propyl to form propanol. So we can do it backwards as well. Okay? That is esterification, propyl ethanoate, propanol, and ethanoic acid. Okay, so with the esterification problems, all right, where do we start? Well, we start with the fact that the ester has got the green, which is the family grouping, double O, single O, all onto one carbon. Okay, then we look at what the side chain is. You can use colored pencils like I've done with the greens and the blues. Okay, find the longest chain with the green. In this case, it's not really relevant, okay, because we're not going to add other things onto the esters at this point. All right, let's have a look now at the cyclic structures, shall we? Yes. Cyclic structures. All right. Cyclic structures, we have already said that we call them cyclo, all right? But what about this if we have one of these? Double bond C, single bond, I've got there, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, like so. Okay, now let's put our hydrogens. There's 2 there. There's 2 there. Remember, you always count. You've got to have 4 bonds around this character, right? And over here, I've got 1, 2, 3, so I can only have 1 H there. 1, 2, 3, so I can only have 1 H there. How do I label that? Well, I say to myself, okay, this is, first of all, 1. What is it? It's a double bond, which means it's an ene. Right? Step 2. How many carbons are there? Carbons, there are 1, 2, 3, 4. There are equals 5. Therefore, it must be meth, eth, prop, pent. It's pentene, but it is cyclopentene. Same if you had cyclopentine, same principles. You first of all look, it's double bond or triple bond. If it's a triple bond, it's an ine. Count the carbons, that gives you your prefix. Okay, non-ine. Okay, 9 carbons with a triple bond in it. Okay, so that's pretty easy, isn't it? Okay, all right. Okay, cyclic. Okay, we've got that. Now, right, let us look at this cyclic structure. How would we take this one? I've got a C and a C and a C over there, and I've got over here a CH3 like that, and I've got a C over here, and I've got another C and another C like that, right? So first of all, it's cyclic. How do we name this, right? Well, first of all, it's all, step one, it's all single bonds. So single means it's an ane, right? Then we say, hang on, I had another one down here, like that, okay? So now I say that's a single ane, okay? Then I say, right, 1, 2, 3, it's a hexane, isn't it? Because there are 6 carbons, therefore we are looking at hexane, right? These are not problems you often see, just by the way. Okay, so if you're getting in a bit of a panic with it, they're not difficult. I think I've only seen 2 or 3 ever in the textbooks I've looked through. So let's say 4, okay? Chances of getting one, they're going to be easy ones anyway. This is a hexane, but it's in a cyclo, so we're calling it a cyclohexane. And no, I haven't finished. I have to number it because I've got side chains, okay? I've got side orders here, sides, right? What have we got for sides? Well, we've got an ethyl and a methyl. A methyl and an ethyl. Whoa. Now comes the issue of numbering. How do I number it? Well, start with the chain over here and go around to keep the numbers as small as possible. Okay? So it's 1, okay, ethyl. I started with the longer one. So it's 1 ethyl because it's on 1. And methyl is on 2. If I'd have gone the other way round, guys, I would have gone 1, 2, 3, 4, 5, 6, which actually means that that number's bigger than it needs to be. So you always keep the numbers as small as you possibly can. So it's 1 ethyl, okay, let's just put it back to it's very difficult to do it in green. So it's 1 ethyl, 2 methyl, all right, and I've left out my hydrogens over there. I could have had 2,2-dimethyl if I'd have got another methyl there, right? Same thing's going to apply. Stick a methyl there. It's like I could have had a diethyl, because don't forget there's a hydrogen. There's 2 hydrogens on each one, right? Like that. So over here, there's another H sitting there. Don't forget to fill those in. Okay. The next one that I've found to have a look at is this one. Okay, something like this. All right. I think I've also got, yeah. So I've got here a C double bond C to a C to a C to a C to a C. I think I've got a hex again. Okay. Okay. Now I say, okay, like that. And let's say over, okay, there like that. And on this one, I've got an H. And on here, I've got a CH3. All right. And on here, I've got a chloro. And over here, I've got another chlorine. And then I've got an H and an H and an H and an H. And over there, an H and an H. All right. Whoops. Too many. Please always check every time you draw these, right? So step 1. All right. Step 1, what must I do? Step 1 is I say, what family group is it? So I look, and my trigger here is that I've got a double bond O. So therefore, I am going to say my family group is here, my red, that's going to be an ene. So I say over here, my functional group, my family group is an ene. Number 2, how many carbons? Count carbon. There's 6. 6 bicarbon, therefore it's a hex. It's a hexene, but it's in a cycloid, therefore it's cyclohexene, right? Ene, hex, and it's circular. Now, I have got side chains. Okay, what have we got for sides? Okay, now how do we number? Okay, the question is, how do we number these? How do we number them? Well, you always start off on your functional group here. All right? You're always going to start off on the functional group, okay, which is in green here. So my option is to say, right, either 1 or 2 or 1 and 2. You always start at the double or the triple bond and look at 1 and 2. One of the ends is 1 and the other's 2. Then you count. If I go this way around, it's 1, 2, 3, 4, 5, 6. Okay? Okay, 1, 2, 3, 4, 5, 6. Okay? Like that. Okay, that's my hexene. But now I could have gone 1, 2, 3, 4, 5. Can you see by going this way around, okay, I have made the numbers smaller. I've got 1, 2, I've got 4 and 5. Otherwise, I would have had 5 and 6 where the side chains were. Let's look at what we've got on the side chains. Blue, I've got a chloro and a chloro. And I've got over here is an methyl. All right? And essentially, if I take the shortest route, 1, 2, 3, 4, methyls on 4, chloro is on 5 and 5. If I went the wrong way, I would have had chloro, chloro, and methyl. So I would have said 1, 2, 3, 4, 5. Can you see? My methyl would have been on 6. Chloro is still 5, 5. But it's wrong because the methyl is too high. It could have been a lower number. We keep those numbers as low as possible. So therefore we say it's a cyclohexene and we have sides. Right. We always put the halides first. So it's going to be, but there's 2. So it's going to be 5 and 5 dichloro, right? 4 methyl, cyclohexene. Okay, have a look at that one. Okay, it's 5, 5 dichloro. All right. Okay, and we've got, yeah, like that. Okay, hexene because we're on 5. All right. Just as a passing one, okay, let's, you can do another one with a heptene or whatever the case might be. I now want to look at alcohols, okay, primary, secondary, and tertiary alcohols. Okay, I did say in one of the previous sections. So let's have a look at alcohols. Remember, alkanol too, okay? They're all alkanes that we're going to be dealing with. But I can have a couple of ols added on, right? To form a diol, triol, tetrol, all right? Depending on where they kind of are, all right? Alcohols. We have what's called a primary, secondary, and tertiary. And tertiary alcohol. Okay, I don't need to say that. I can leave it off. Okay. We have primary, secondary, and tertiary alcohol. How do we find the difference? Well, let's take a simple alcohol like this. What is it? Step 1. Family, it's an ol. Okay. Then I say, right, long chain. Where are we? There we are. So it's a meth-eth. This is then going to be ethanol. Correct. Okay, ethanol. And it's on 1. Okay, and it can't be anywhere else. Okay, it's on ethanol. Right. Now, okay, so the first step is that this is a primary alcohol. Primary alcohol. What do I have to do? I locate, first of all, COH. Locate on its own this guy here. All right? Locate that. So we locate the alcohol. Okay? That is this one. This is what? If I had an H here, it's methanol. Okay? You drink ethanol, by the way. Methanol is that purple stuff, methylated spirits, and it's highly toxic. So you've got here, okay, ethanol. You locate that. Then the next step is you say, okay, this is actually just straightforward. Just watch. Locate the alcohol number 1. Then look, step 2, look at how many carbons the methanol, whoops, not as, is linked to. So in this case, with ethanol, it's linked to, what do I do? OH, H, H. Okay, there we go, like so, right? Step 1, I find my base alcohol. There it is. And I then look and I see it's added to 1. Therefore, it is primary alcohol. Okay? What is methanol? It's the simplest alcohol. Methanol is the simplest alcohol that you get. You can't get simpler than that with an alcohol, can you? All right, so there we go. Now we say, all right, let's take the next logical step up. Okay, go to black. The next logical step is we're going to add, okay, this. Like that. Okay, right. We said find, those are all hydrogens that have been added. Okay, first of all, it tells me that it's an alcohol. Secondly, I have got over here, okay, my primary is there, right? Or sorry, my first. And then I say, right, therefore, I now look and I see that my C with my OH, and there's an H there, is linked to 2 other carbons. Therefore, it's a secondary alcohol. Okay? And if it's linked to 3, what is it? It's a tertiary alcohol. Yep. Okay? It's a tertiary alcohol if it's linked to 3. So let's do this. C, 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 like this. OH. Okay, C. Can I just tidy that up a bit? C, like so. Like that. So I say, I found my first. There it is. And I look and it's linked to 3. So this is a tertiary alcohol. Let us name them. All right. Okay. The first one at the top here, I have to find my longest string. It could be that way. Let's say I chose, I've already put the green on. Let's say that way. Okay. So what have we got here? We've got 1, 2. So we've got ethanol. Okay, because we label 1, 2 that way. And it's 1 methyl. Okay, 1 methyl ethanol. What would the next one be then? Well, similar story. It's once again, we find that we've got our longest chain over here. Let's go green, and we've got this over here, all right? Now we say, right, 1, 2, 3. So what's it going to be? It's 3, so it's meth, eth, propanol. But it's prop and 2 ol, because it's the ol is on 2. Meth, eth, prop, and ol, there's the ol is on 2. That was the side chain. Let me just do it. Sides. Okay. We've got an ol on 2. And we've got a methyl on 2 as well. So therefore, I've said, right, there's where my is, and it's also 2-methyl propan 2-ol. Okay. Carbons attached to it. Okay, and that's what we've got there. Okay. 2-methyl propan 2-ol. All right. Please note, okay, that we can get diols and triols. All right. Propan 1, 2. Now let's say they tell us this. Okay. Let's say they tell us that we're given propan 1, 2 diol. 1, 2 diol. And they say draw it. Well, step 1, it's an ol. It's an alcohol, so it must have an OH. Okay. Prop, meth, eth, prop. So it must be a meth, eth, prop. Okay. But now diols means there are ol and there's another ol. Where are they? They're on 1 and 2. And then you finish it. Right? Like that. Okay, pretty straightforward. 1 and 2. Propan 1, 2, diol. All right. You can have a triol as well. All right. Let's have a look at this one. Propan 1, 2, 3, triol. Okay. Here we go. Propan 1, 2, 3, triol. Okay, first of all, it's an ol. So there's an ol. There's 3 ols here. And where are they? They're on 1, 2, 3 of a meth, eth, prop. Meth, eth, prop. You know they're all single bonds because we're only doing alkanols, right? So we say, okay, meth, eth, prop. Put in our bonds. OH is on 1 because it's an ol. OH on 2. OH on 3. Like so. Right? No problem whatsoever. Can you see the rules just keep coming in? There's another one here, okay? We also get an ol, which can be in a cyclic form, okay? I think I'm rather not going to do that. Or let me just do it, just for peace of mind, okay? I'm just going to show you this one here with a C, okay? C, like that. 1, 2, 3, 4. There's 6. And I'm going to put an H over here and an OH there, another OH here, and an H. And then the rest, I'm going to leave like that. Okay. Oh, by the way, just wanted to give you the name. This one here is glycerol. Okay. Just so that you know. It's glycerol. Is propan 1, 2, 3 triol is glycerol. Okay. I haven't seen it used much, but I have seen it in some. What I've tried to do is to put all of this out of like 5 or 6 different sets of textbooks and study guides. So we've got that. How do I label this? Well, first of all, I say, okay, essentially, what have I got here? The functional group is an alcohol. So I check. Aha, it's an alcohol because it's got that on it. And there's an ol and an ol, so it must be a diol, correct? I think I had another alcohol. Yes, I did. Okay, sorry, I got another alcohol here. Okay, like that. So I have found my functional groups. They are alcohols. I've got 3 ols, therefore it's a triol. Okay, it's a triol. Now I know that it's cyclic something, but I don't know yet what its name's going to be. Okay, and it doesn't always attach like so. I want it to move up slightly. There we go. All right, now the next step is we've said, okay, it's a triol. Okay, so we've got that. I know that. Then I say, right, how many carbons? Okay, there's 6. So it's going to be a hex. Okay, hexa triol. But 3 ols, I have to tell you where the 3 ols are. How do I label it? Well, I go to my green and I say, right, I label from the functional end 1, 2, 3. I label to make sure that I get the minimum integer value. I could have gone the other way. I could have said 1, 2, 3. Okay, that would have been the same. No problem. Could have gone like that, 1, 2, and 3. But if I'd have gone around, all right, and gone 1, 2, 3, 4, 5, 6, I've made a mistake because my integer values have become too high. So this is going to be hexa 1, 2, 3 triol. And lastly, my final name, cyclo hexa 1, 2, 3 triol. Like so. Okay? There we go. Now the next we're going to do is reactions in organic chemistry, right? That's actually been quite fun going through. And I'm going to come back and I've said before, we're going to put more examples into this. We're trying to get the theory with as many as possible examples and then going to run some examples pertinent to the theory specific. And then we're going to throw in some examples and do more. Cheers. Thanks for watching that section. As I say, the next is reactions of organic chemistry and physical properties of the long chain molecules and why. Chat to you again. Cheers. Bye.